Hello, D4D. Nick Colley here, and tonight we've got a wonderful tutorial from a D4D member, Tim, who's going to be talking and walking us through how to use Docker, a really great tool for managing environments and allowing you to test your code in other environments and also help share projects amongst one another. But before we dive into that, wanted to quickly talk about the hackathon that's coming up. So for those in the community, you may be aware that we have the Infinite Mirror hackathon coming up, where uh, it's the same thing as before. We're going to set some time aside for people to come on and work. We've got more sites, more locations. So check the general channel and the hackathon channel on our Slack. If you're not a D4D member, feel free to join on the contact, and we'll get you involved in the community. The hackathon is going to run from September 29th to October 1st, and each site location is going to offer a little bit different times or different themes for the execution. So again, check the general channel out, and you'll get all the details there. But Tim, welcome to the D4D Hangout. How are you doing tonight?
Good. I'm good, man. How are you doing?
Doing very well. So Tim, you are in information management. How do you come across Docker? How did you come across using Docker?
Well, primarily, actually, right now, I'm using it. Our systems are obviously very contained. At where I work at, we're kind of restricted with some of the applications that we can use. But with Docker, I'm able to use some of the other programming languages, like Python, and in my particular case, R, to run some scripts that I need to analyze some of the data the way that I'm more comfortable with, to get away from Excel and access things of that nature. And then in my site environment as a hobby, I use it for my package development. I developed some packages for R, and that's actually how I got turned on to it. Was I needed that ability to test and develop under different environments with limited resources.
Okay, so Docker is kind of like a container that allows you to spin up different environments on your machine.
I would say that probably the best way that I could explain it would be like using Amazon Web Services. Yes, you're limited to whatever your resources are. So, in my case, I have a 4 GB memory computer to process or something like that. So I'm limited in that aspect. Docker uses those resources and allows me to create different types of images for different type of platforms that I need. So if I wanted to spin up a Jupyter notebook isolated from the rest of my computer, I could do that. If I wanted to spin up an RStudio environment isolated from the rest of my computer, I could do that.
That's awesome. So for those watching on YouTube, if you're part of the Slack channel, feel free to ask questions on the Slack. We are monitoring it, and also if you're on YouTube, feel free to ask questions there. It's over here on this monitor, so feel free to ask, and I'll make sure to get your questions passed on to Tim during this tutorial. Tim, you have the floor.
All right, thank you. Let's see here. All right. So I'm going to begin with the assumption that pretty much everybody has already installed Docker. Docker is available for Macintosh, Windows, and Linux OSs. Setting up on Linux is fairly straightforward and easy. I installed it on my Ubuntu 17 with no issues at all. I did also install it on Windows 10, and I don't have as many issues, or I don't have too many issues. One of the things that I found a little bit odd, and this was completely new for me, is that it actually apparently comes with a virtual box that you have to open up, I guess, access for Windows to Docker. So if some of you have any issues installing Docker on Windows systems, that may be one of the things that you want to look into. But so once we get
got
Docker,
a quick question.
All right.
Real fast. So a minute ago, you had referenced that on your limited computer machine, you'll spin up a Docker instance of Jupyter Notebook to kind of keep things separate. What's the overhead like on the host machine when you spin up these virtual environments?
I really don't have any overhead. So my computer is really kind of on the slow side, and that's when I started using AWS. Um, when I when I first started using Docker, I think I got a little carried away, and I actually did freeze my system. I think I just tried to download too many images at once. You can see that right here. I've got, I don't know, 10 or 15 images. They're all pretty substantial, between 1 and 2 gigabytes. And I actually have right now about, sorry, let me go back here for 1 second. I have 4 or 5 images that are actually running right now. And, again, my computer is not an advanced computer. This is not something that you would run some complicated algorithms on. So being able to have those running all the time, and it's not slowing down, it's not hogging my system, to me, it's a huge advantage. It's a noticeable difference. It's actually one of the reasons why I went over to Linux, because I felt originally I had a Windows 7 computer that was really slow, and I ended up installing Linux on it, and everything was running better. And then Windows 10 was running good as well. So as far as resources go, I think to me, it's nice. It's smooth.
Okay, awesome. Thank you.
Okay, so yeah, so Windows, I don't have a Mac system, obviously, so I've not even tried to attempt Mac. I don't know how complicated it would be to install Docker on that, but um, so with Windows users, you may want to look into this virtual box if you have any complications installing it, but for the most part, it should be pretty simple and straightforward. I was up and running with Docker on this Windows 10 within an hour. I didn't have too many complications at all.
When I
So
installed Docker, it installed for me the virtual box already. So I don't. It depends on the link, I guess.
yeah, and a coworker of mine, he attempted to do it on his Windows 7 machine, and he had a bit more complicated issues, but I'm not sure. I'm not sure if it was just because of his personal setup or what, but I don't know. I'm not a Windows expert.
We'll post the link for the installation from the Docker website in the doobly-doo down below.
I'm sorry, do what?
We'll be posting an installation link in
Oh,
the description of the video below.
all right, good deal. So once Docker was installed, I basically had this little Docker console terminal that I pretty much run almost. Docker quick start terminal is what it is. In Windows, in Linux, you can just access Docker from the terminal. Generally, when you know that you have Docker installed correctly, you can run the Docker run hello world. And so what it does is, this is the basic command to get started. You can see right here, it's downloading these images that are necessary for this application. It's basically a confirmation that Docker is installed, everything's set up, it's running smoothly, and you're good to go. So the hello world is its own isolated image, probably downloaded from Docker Hub, which I'll get to in a minute. Windows users will open up the quick start terminal, all right, and you can kind of see it's a nice fancy graphical representation of what you can do, and then I'm getting a brain fart. Docker images. So we pull up the Docker images command, which lists all the images that you have installed. You're not going to have any installed initially right away, of course. So let's say that in this example, if you're building a Python app, you might want to start with a specific version of Python 3.6. There is a repository called Docker Hub, which is pretty much where all of the core of the images get downloaded. Let's do a search for Python. You can see there's the official Python repository. And you'll see a lot of this, supported tags and respective Docker files. So these are the different images that you can download of Python. So if you wanted to go back and test an application with 2.7.13, you can pull this specific image onto your system, fire it up, and immediately start doing your test. Obviously, there's a number of choices to choose from. So in this example, let's say that if I wanted to pull the Docker, or excuse me, the Python 3.6.2 stretch, you would type in the, well, it gives you the command, the base command right here, Docker pull Python, right? And then we do a colon, and we will use the tag that of the image that we want to download. You can also view tags here. There we go. And you can see so not all the Docker Hub repositories will have this security scan. Now, let me address the security issue right away. I am not an expert with security on Docker. Let me get that out of the way right now. I do not run Docker for other people's uses. I run it for my use. I do have images that are available in my repository that others could download and use if they wanted to, but obviously the security factor would be on them to ensure that it doesn't affect their system. Some of the things that I've noticed when trying to read up on this issue is limiting root access. Root access could potentially give other people access to your file system. So that's one of the things to be concerned about. The other thing is using default usernames and passwords.
So you're saying that if you were to create, or I were to create a Python package to share amongst the community on the hub, that we obviously don't post your passwords in there, but when you upload it to the hub, it's going to scan it to see if there's vulnerabilities out there. Is that the understanding?
To an extent, the scanning is paid. So if you have one of the paid services, I use the free, so I don't worry about the scanning. But there's different services here that you can do. And as I understand, scanning will be performed on any of these paid services. So this is the thing that I've found interesting, and to the best I can understand, you'll notice all of these say that there's some vulnerabilities. I've seen this everywhere. I ignore it. I mean, it's the best way to.
It's good.
Yeah. If you can see the types of security vulnerabilities that there are. So if you're more of a security expert than I am, maybe some of this will stand out to you. Maybe you can fix some of it. But for the most part, me personally, I don't worry about it. It's there for your information. So going back to here, we have all of these tags. And let's say that the first one that was put down, this Alpine, go back up here. This is the tag that we're going to use. So we'll type in :3.4-Alpine. And what's going to happen is it's going to start pulling down all of these images that I've not already downloaded. So the initial time that you pull an image, it may take several minutes. But if if you already have some of the core images installed on your system, then it's going to go much faster for you. So most of these images are going to be based off core images, such as Ubuntu. There might be a core Ubuntu image. There might be a core Python 3.6.2 image. And then if you pull a Jupyter Notebook, it's going to use that Python image basically stacked on top of it. So each of these images are different layers of information that come together to create one core system that you can begin running your container off of. So images are built from what's called Docker files. If we open up this Docker file right here, it's just a simple text file. It's basically a series of commands. that Docker uses to fire up what it needs. So here we're basically telling it to start from Python 362 stretch. That's the base image that we want it to use. This is our working directory that we want the user to work out of. And the add command takes everything that's in this directory, represented by the period, and puts it into this working directory. The run command is basically the commands that are going to run once the Docker image is fired up. So we're going to install everything that's listed in this requirements text file, which is basically some Python modules. So this app is for the streaming Twitter Python app, which was another tutorial that was featured for Data for Democracy some time ago. Nick, you might know that better than I do. But this is the repo that was based from. So basically, I took this Python notebook here and moved it into a Docker container. So the requirements, it required the Python modules tweepy and dataset. And then in addition to that, I also had it install VIM because I like working in VIM if I need to edit anything. And then additionally, SQLite 3. SQLite 3 and Vim are not part of the core images that are used in many of these packages. So most often, if you want any additional software, you'll have to install it. These images are built off very, very base operating software images, stacks.
Okay, so if I'm understanding it correctly then, you're saying that we've got a container, an empty container, and you've just installed Python, and then you've asked it to also install SQLite and upgrade it to the most recent version, Tweepy and Dataset, so that now you've got one container with Python and all those extra things built in and ready to go.
That's correct. And most of these images, at least with the Ubuntu images, the Linux images, you'll need to run the update and upgrade commands because like Vim and SQLite 3, they're not in the base repository. So once you run the update and the upgrade, then they will be there, and then you can go ahead and begin installing those.
So the real advantage to this then is instead of a VM on our virtual environment with Python, where you're only managing the libraries you have access to, here you're setting up an environment where you're specifying the type of Python, the Python packages, and any other software requirements like SQLite that normally isn't tracked on the virtual environments.
Yeah, I've not used virtual environments, so it's hard for me to explain the advantages and disadvantages of each one. But you are correct, and so I'm basically building an operating system off of these commands, and it's completely isolated from my computer. I cannot access anything that's inside within reason, I cannot access anything that's inside the container from my computer, and vice versa. So that's one of the things that I really love about Docker is because when I'm developing packages for R, I might need to test different versions of R. I might need to test different versions of R dependencies, such as dplyr or any of the tidyverse packages, right? With Docker, I can have different combinations of those packages and R on any of these different images that I have. So it really gives me much more flexibility to create the environment that I need in order to do the testing and the and the development that I need, and make sure that it works on other people's systems as well.
That's really cool.
Yeah. So once we've written our Docker file, what we're going to do is I'm going to come over here, and guys, please bear with me because I am not used to working in the Windows terminal. streaming, if I can spell correctly. I'm just going to navigate, make sure that I can navigate into, all right, there we go. I don't know if that's showing up for you guys like it's showing up for me, but all right. So once I've built my core Docker file, we're going to go into the root directory, and I'm going to run a simple Docker build, and I believe, I knew you were going to do that.
And for those wanting to follow along, all these steps are in the GitHub link that is in the description below as well.
All right, so I was trying to pass a flag there that I didn't need to. So now, let me enlarge this. So now it's running through. You can see right there, it's installing the modules from the requirements file. So or it's going to take a few minutes, so I'm just going to minimize it here in a second. But it's going through everything, all the instructions that I've listed in that Docker file to install this application. Again, the initial setup is pretty quick, or excuse me, takes a little bit of time, takes a few minutes depending on the other resources that you may have already downloaded. But once you have the image done, you can fire it up at any time. That's another advantage that I've read using Docker containers over virtual environments, is those virtual environments may take quite a while to load every time you do it. Whereas with Docker images, once you fire up an image, in seconds it's running, and you can get into it, you can access it from the web if you've allowed it that access. So pretty much you can get going right away. So once we've started building an image, we get what's called containers. All right, so containers are running images. This is where we're going to go to do our work. You can see I have a number of images, or a number of containers that are already running. So let me just explain what all of these fields are. The container ID, that's like a unique ID, pretty simple. Image, this is going to be the name of the base image that the container is running off of, any extra commands that have been supplied to run the container. And then created in status, you can see most of these containers are still up and running. Actually, it looks like my Python image is already up and running as well. Ports, if you've opened up any ports, you can do port forwarding, just like if you wanted to open up a Docker container as a web server, or if you needed to use a Docker container to access Jupyter Notebook or the RStudio server IDE. And then more language-friendly names that you can reference the containers by. So now that we have, so we've already built this Python. Let's go back up here into our images. And where are you at? Looks, this is the one that I first downloaded. It looks like this is the one. Oh, no, it's not. I'm sorry. It's way up here. Okay. So this is the image that we just created off of that original Docker file. Now, what we can do next is run this container, and I'm going to have to use the image ID. So we'll do the Docker run Docker run command. The TI flag keeps the container interactive, so we can access it from the terminal, as well as if you're running a Jupyter Notebook or an RStudio IDE, so you can access it from the website as well. And I'm going to name this container streaming Twitter, and I'm going to pass 8449B, the image, oops, the image ID that was created. And now you see that we have this nice long hash here, no errors. So if we go back down here and view our list of containers, see there is our streaming Twitter container that is now running. So now that we can get into this container and we can begin running our streaming Twitter app that we had earlier. So to log into a container, we use the exec command with, again, the -ti for interactive. We pass the container name and then the command that we want to run, which is in this case bash. We want to actually get into our system. And now we are logged in inside of our container, and notice our working directory is the same working directory that we set up in our Docker file. To list our directory contents, there's all of the files that we created in our original directory. It's all been copied within the container. I do want to kind of go back to the security issue for a second, because one of the things that I've struggled with when in developing is using passwords and other environment files inside my containers that I do not want stored on those containers. So there's a couple of ways of getting around this. Some people, what they will do is they will pass environment variables into the container either by the Docker file or by passing it in as a command. This is not recommended. If you run the Docker inspect command, oh, come on. Let me go back here. What's this?
It errored out because you were inside the actual Docker runtime environment, the container.
You know what? It did. You're correct. So you can see that there's a lot of information. So again, this is the Docker inspect command. So you can basically view a ton of information that was used to build this image. Environment variables are going to be stored in this image. So if you pass anything like passwords or anything sensitive of that nature, it can be viewed. One of the ways of getting around this that I've used on occasion is attaching a volume. And so what that means is, if let's say that I wanted to copy instead of copying everything from, or instead of adding everything from my current directory into the image on build, I could leave all of this out, right? But then when I run the image command, you would, or excuse me, yes, when I run the image command, you would probably pass it the -v flag for the volume. And you would basically map your working directory on your host computer to your working directory inside your container. All right. This is advantageous because it hides the information from the core image, and when you shut off the image, it's no longer there. So it's not static within your container. It's not static within your container. There's been several I'm sorry, I lost my train of thought there. So, right, maps your host working directory into your container working directory. The other thing that you can do, and something that I've preferred, is using a copy command, which is once an image is running, you can copy, if you have an environment file or something like, you can copy that file into your working directory. You can do it, but the problem with that is that it stays in the container. Even when you shut off the container, it stays in there. So the best bet is just going to be to attach it as a volume, and then once the container is shut off, it gets detached. but don't store any personal information inside the containers. This is basically what I'm trying to get at. All right,
Right. If
so
you're intends to share, then you're boned.
I'm sorry, say that again.
If you're intends to share the container and then but you put your personal information in, then you have a security hole.
Right.
It's
Yeah,
yourself.
and even the ones that I store, even the ones that I store in my Docker hub, I don't keep any information there because I just don't. I'm not comfortable enough with that level. So I'll just attach the volumes, and then for me it's just easier. I don't have to worry about any of the other stuff. Um, all right, so I've logged back into the Docker container here, and what I'm going to do is go ahead and I'm going to run this streaming Twitter Python app. And so, for those of you that may not be familiar with with the original tutorial, basically what it did is it grabbed 10 sports-related tweets from Twitter and moved it into an SQLite 3 database. All right, and you can see that that's what it's done here. We've got something about Fister throwing 7 shutout innings, and I don't know who that is, but good job. And then there's a football tweet, another football tweet. Um, so the app's already run, it's done, good for it. And now the next thing that we'd want to do, of course, is check our database and make sure that, oh no. Try this again. Oh my goodness. Well, it was supposed to be installed. So I messed up in the Docker file, and I do apologize for that. I could have swore that I tested this several times, and it worked. But anyway, you have your SQLite 3, access it, verify that the information's there, and run the app. All the tweets would be in there. In this case, so what I do, in this case, I made a mistake, right? That's not, I mean, that's okay. Well, it's not okay for this, but it's okay for what we're doing. What you can do, if you don't want to rewrite the Docker file and restart from scratch, what you can do is you can make modifications to a container. You can make any modifications if you want. So let's say in this case that my Vim editor didn't get installed either. I'll install the Vim and the SQLite 3 database, and then I run the Python app again, everything runs fine. Well, now you have a container that's not identical to the image that you've created. You can save containers as new images, and the advantage to this is that it also allows you can use tags to kind of benchmark your containers as you go along. So let's say that you're working on a package that's at version 001. You make some modifications to it. You don't want to get rid of your original container. You don't want to get rid of your original container, but you want to obviously have a new container for 002. So what we're going to do is I've just upgraded the software, so we'll leave it at that for now, and I'm going to get out of the container and go back to my root system. Oh, let me get rid of this, excuse me. So streaming Twitter is our name, and we have our container ID, which is listed on the far left side. I'm going to stop that container. You can use the name or the container ID. My knowledge for all of these commands. I've not come across any commands where you have to explicitly use the container ID. So we're going to stop this. eventually. There we go. All right. And now what we're going to do is we're going to commit this as a new image. And in this case, I'll use the container ID 9701E. And after that, I'm going to pass it a repository name. So one of the things that I try to do when I'm saving my images, for very generic images, I'll just leave the name as whatever. Like in this case, it's just a Postgres database. In this case, it's a specific project out of my GitHub. This is a specific image that comes from the Rocker Docker Hub. So I try to add some detail there so that I can keep track of exactly what the image is and what it's for. So in this case, I'm going to do Tim Trice streaming Twitter. And again, this is just the repository name. And let's add a tag to it. All right, let's just say that this is version 001. I should put a -A after there for alpha. Okay, I mistyped the container ID. Let's try this again. And you'll do this with the Docker commit command. So and that's taking your container and that's freeze framing it. We go back, use the Docker images command, and now you can see we have a new base image. There's our repository name, there's our tag, and then image ID, and so forth. So the container still exists in your list of containers. It stopped, we stopped it, but we didn't delete it. Excuse me, we didn't delete it. If we want to do that, we use the docker rm command. rm for remove, and then again we can either use name or the container ID. I'll use the name. And it is no longer there. So we go list Docker images. Still have our Docker image. So now the next thing I would like to do is to push this into my Docker Hub. Docker Hub is just similar to GitHub. Let me go back over here and give you guys an idea of. So this is, come on. So this is the home page of each repository. And you can see you've got your short description, your full description, kind of similar to what you might have on GitHub. All of your information that you want to include, this is all just a README file. This is all in Markdown text, basically giving as much information as possible to anybody that's going to download your images on how they can use your images. It does not keep track of the changes. In other words, if you push an image into Docker Hub, let's say Python 3.6.2, and then you push 3 days later another image, Python 3.6.2, it's not going to be layered version controlled. It's just going to overwrite the previous image. So keep that in mind. Try to use the tags every time that you're creating one of your, or whenever you're uploading one of your new images. So in order to push these images into Docker Hub, we need to log in from the Docker, or excuse me, from the terminal. I'm just going to log in real quick and login succeeded. So now we use Docker push, and then we will do the Tim Trice streaming Twitter with tag, or excuse me, with tag 001-A. And anything that the image relies on to operate is going to get pushed into that repo. This is going to take a while, or it will take a little bit of time, but all you're going to be left here when all is said and done is this is an image that was pushed into Docker Hub. I apologize for not having much information on it, but can you hear me? God. So once we've pushed into the repo, let's go back over here. You see all of our supporting images have been pushed. Let me hide this. Apologies. And there is our new image. Come over here, you can add your short description, full description. Full description, again, it's just markdown text. That's all you need to add, or just plain text. And there's our tag number. Now, again, as I mentioned earlier, if you have the Docker Hub, any of the paid services, there is the scanning service that they do provide on each of your repos. You'll see that that's listed right over here. I do not have the paid as of yet. Nothing personal against them. I will be at some point. And then all this other information, honestly, I've not even tried to look at all this. I don't have a clue what all that's for. So let's go back to our console. And now we can remove that image. Sorry, let me go to another one. Let me list the images again. There's our Tim Trice streaming Twitter, Docker. To remove an image, you're going to use the RMI command. So Docker RM is to remove a Docker container. Docker RMI is to remove an image. And with that, you'll pass the repository along with the tag and it is gone. We no longer have our streaming Twitter app. When we are ready to begin working, just come back over here. That moment when it's just easier to type it out. We can just pull it back into our system and continue working where we left off. So that's a basic rundown of using Docker. The reason that I began using Docker, to add a little bit of history, if you don't mind, is when I was developing a weather package, a hurricane package for the R OpenSci community. And I had an issue where one of the packages that I was using was working fine on my Linux system, but it was not work. Somebody had pointed out that it was not working on theirs. Actually, I'll take that back. It was failing in one of the AppVeyor tests. So AppVeyor test on Windows, whatever, and the test kept failing. I couldn't quite figure out why, so I got into my Windows and tested it and figured out what the issue was. But it really stressed upon me how important it was to try to create as much of an environment as I can to where I could test from different systems. I'm not an expert with Travis. I'm not an expert with AppVeyor. So if I push changes to any of my code into a repo and the tests fail, I might not be able to clearly identify exactly why it failed. Whereas if I can recreate the environment, I can go through and see exactly which test it was and exactly why it failed, and I can fix it from that container. That was most important for me, is being able to fix it from within that container. So if I could have, in my case, I could have dplyr 050 installed on one container, and I might have dplyr 070 installed on another container, and I can make sure that my package works regardless of the dplyr version that I'm using. My minimum requirements is that it's greater than 050, so I can test 050, 070, 072 on any number of containers that I wish to. And if there's any bugs, I can fix it, or I can just say, okay, we're no longer going to support dplyr 050, drop it, and basically upgrade the package from that point forward.